Okay, let's get rolling with the stuff that we're doing today. So again, I'm going to check these notes to make sure you're copying everything down just like I'm doing on this video. So make sure that you're not skipping anything. You have nothing better to do right now, so just make sure that you're following along and getting this stuff done. This is stuff that you've done before, probably in middle school and then in Algebra 1 last year as well. Midpoint and distance formulas. So for a midpoint, on a number line, all we have to do is just take an average of the 2 points. So for these first two problems that we have here, if I want to find the midpoint of 4 and 9, all I want to do is add them together and then divide by 2. So negative 4 plus 9 gives me 5. 5 divided by 2 gives me 2.5. Second one, same thing. And negative 8 plus 11 divided by 2 gives me 3 on the top, divided by 2 gives me 1.5. When we move into the coordinate plane, we're going to take an average of the x's and then an average of the y's. So formula for this would look something like this. X1 plus x2 divided by 2. That's just adding my two x coordinates together and dividing by 2, just like we did there. And then y1 plus y2 divided by 2. And that'll give me an ordered pair for my midpoint. So for this first one, remember, this is my x, this is my y, this is my x, this is my y. So I'll add together, so I'll go 7 plus 2 divided by 2. Remember that these two numbers are my endpoints, and it'll be equal to whatever this number will be, my midpoint. So for my x's, 7 plus 2 divided by 2, so that gives me 9 divided by 2, which is 4.5. And then same thing for my y's. I'm going to add those together. So 5 plus negative 4 divided by 2. That'll give me 1 divided by 2, which is 0.5. Sometimes it's easier to do if you have a piece of graph paper, so we can plot these 2 points. So we've got 7 and ordered pair 7, 5, so 7, 5 is right here, and then 2, negative 4. What I can do is connect them by a straight line, and so kind of an easy way that I can do this is I can turn this into a vertical and a horizontal line. I know that this vertical line right here is 1, 2, 3, 4, 5, 6, 7, 8, 9 units long. And I know that this one right here is 1, 2, 3, 4, 5 units long. And so cutting each of those in half, 5 is 2.5, and then 9 is 4.5, so 1, 2, 3, 4.5. And so I know that they have to meet where those two intersect, which is right there. And again, that's the same as I had there, the ordered pair 4.5, 0.5. So just kind of two different ways of doing it. One's graphically, and then one is by using our formula. So with the second one, same thing. For my x's, again, I'm going to go negative 3 plus 2 divided by 2. That gives me negative 0.5. And then for my y's, I have negative 6 plus negative 1 divided by 2 gives me negative 3.5. So graphically, again, I can do it. Negative 3, negative 6. And then 2, negative 1. And then I can connect those together and turn it into a vertical and a horizontal line. This distance right here, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So this distance again is also 5. So I can cut them both in half at 2.5. So I find that my midpoint should be right about there, which again is that same ordered pair. Negative 0.5, negative 3.5 for my x's and my y's. With the next ones, so these are the ones where I'm going to be working backwards. So it tells us that S is the midpoint, and so it gives us R, which is one of the endpoints. Do that in blue. R, which is one of the endpoints, and then S is the other midpoint, which is -1, +1. And so if we're going to use algebra for this, the way that we can do this is we can set up an equation for our x and for our y. So for x, again, the two numbers in the top of my fraction in that formula are going to be my endpoints, so I don't know one of them. And then the other endpoint is -6 divided by 2 is equal to my midpoint, which we know that our midpoint here is the x coordinate of our midpoint is -1. So remember, this is my midpoint, this is my endpoint. And so to solve this algebraically, I can just multiply both sides by 2. Get x minus 6 is equal to -2. Add the 6 and get x is equal to 4. Same thing with my y coordinate. So I don't know my one endpoint plus my endpoint that I know is -1 divided by 2 is equal to my midpoint of y coordinate, which is +1. So when I do that, again, same thing. I want to multiply both sides by 2. Get y minus 1 is equal to 2. Add the 1 to the other side and get y is equal to 3. And so I know that my midpoint is going to be the ordered pair for 3. The other way that I can do this on a graph, which makes it kind of easier, is I can graph the 2 points. So R is -6, -1, and then S is -1, +1. And so again, I can connect those together and turn it into a vertical and a horizontal component. So for this one, it's kind of the same idea as slope from algebra last year, is I'm going up 2, and then I'm going to the right 1, 2, 3, 4, 5. And so if this is my endpoint, this is my midpoint, I know that the other endpoint has to be over here somewhere. And so what I can do is I can just repeat my pattern. So I can go up 2, let's go up 1, 2, and then right 1, 2, 3, 4, 5. So there's where my other endpoint's going to be. This right here is going to be my t, which is the ordered pair 4, 3, just like we found out by doing it algebraically. Then the second one here, doing it again. Again, same thing. Let's do it algebraically first and then do it on the graph. So I've got my x and my y. My x, again, is going to be x plus my x coordinate of my endpoint, which is 2, divided by 2 equals 6, which is the x coordinate of my midpoint. I want to multiply both sides by 2. Get x plus 2 is equal to 12. Subtract 2. Oops, I don't have to show it. And that gives me 10 for my x. And then for my y, same thing. Y plus my y coordinate of my endpoint, which is 7, divided by 2 is equal to the y coordinate of my midpoint, which is 1. Remember, this is my midpoint. This is my endpoint. So when I do that, again, I'm going to multiply both sides by 2. Get y plus 7 is equal to 2. Then subtract the 2 to the other side and get y is equal to -5. So my midpoint is going to be the ordered pair 10, -5. And so doing it graphically again, 2, 7, there's my first point, and then 6, 1, there's my other point. So I'm going down, that would be 6, right? 1, 2, 3, 4, 5, 6. And then to the right, 1, 2, 3, 4. Good. So what I want to do is repeat the pattern. So again, go down 1, 2, 3, 4, 5, 6. And then 1, 2, 3, and 4. So again, I'm going off the graph. You guys can draw it off to the side of your page. But again, I know that my y coordinate is going to be down here at that -5. And then if I count to the right, let's see. And this is 7, so I'd go over 3 more, and I would get to that 10 for my x coordinate and -5 for my y coordinate. And then the last thing, flip over to the back, is my distance formula. there's a couple different ways you can do it. I'm going to do it a way that's a little bit different. So the first one, if you want to use the distance formula, you just subtract your x's, square it, subtract your y's, square it, add them together, and take the square root. The way that I kind of think of this is by doing Pythagorean theorem, which is that a squared plus b squared equals c squared. And so what I want to do is I want to find the change in my x's plus the change in my y's is equal to the distance squared. So for this particular problem, the distance between my x's, so the distance between 6 and -3, is 9. The way that you can find this out is you can take the bigger one and subtract it from the smaller one. So 6 minus -3 gives me 9. Then the distance between my y's, the distance between 5 and 4 is 1. So 1 squared is equal to d squared. So what I can do is 9 squared is 81. 1 squared is 1 is equal to d squared. So I get 82 is equal to d squared, and then I can take the square root of both sides. When I do that, take the square root of 82, I get d is equal to 9.06. And again, I can do this on a graph by making it into a right triangle. So 6, 5, and -3, positive 1, 2, 3, 4. So if this is my triangle, again, I can make it into a vertical piece and a horizontal piece. So I know it goes up 1, then it goes to the right 1, 2, 3, 4, 5, 6, 7, 8, 9. And this is D. And then I can set up my Pythagorean theorem like that. Same thing with the bottom. For the bottom one, how about we go ahead and use the distance formula just in case there's any confusion. So again, big square root sign, subtract my x's, so I go -3 minus -6 squared plus 12 minus -1 squared. So when I do -3 minus -6, I get 3 squared plus 12 minus -1 gives me 13 squared. So inside 3 squared plus 13 squared gives me 178. And the square root of 178 gives me 13.34. Again, it would be the same thing if on my graph I did -3, positive 12, so -3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Oops. There's my 1 point, and then -6, -1. So again, I can connect them together and then turn it into a vertical piece and a horizontal piece. And so again, if I'm counting, I go 1, 2, this is 3. And the other one, it goes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Just by counting, and then I can set up the Pythagorean theorem and get the same exact answer. Okay? So either way of doing it is fine. Do whichever way you would like. So there's your homework. So as soon as you're done listening to this video, there's a Schoology quiz on Schoology Quiz. Do that first, and then do your homework when you're done with that. I'll check the homework tomorrow at the beginning of class.